Hey Science 9, welcome to the little extra video on series and parallel circuits. So you watched a video previous to this and did some exploration with some questions. We're now just going to do some quick notes. So here I have an example of a series circuit, reminding yourself series circuits, everything runs in line with each other. What we want to talk about is how to remember what is going on with voltage and current. So in your notes, you will see that you were supposed to write down that current in a series circuit is the same at any point. So if I had a make-believe point A and point B here, if I was running this, I turned it on, and I had 0.2 amps running through this part of the series, it would be 0.2 amps running through this part of the series. So the current is the same at any point. And that's just simply because current is flowing all the way around in one direction. It's not split up, it's not changing any direction, it's going through all the same wires passing through in one straight line, even though it's technically a box in this case. It's a little bit different when we talk about it in voltage, though. Remembering from the video, voltage is now the potential difference of stuff. So we have here an example of a series circuit in which we have 3 light bulbs. The voltage coming out of the battery is 6 volts. If I only had 2 light bulbs, for example, in this series circuit, each light bulb would get 3 volts because we're splitting it up between all the loads. So in a series circuit, the voltage is always split up. The example in front of you are the light bulbs, all identical. And in this case, there's now 3. So rather than each light bulb having 3, each light bulb would have 2. So it splits it up equally amongst all the loads. That is in contrast to current and voltage in parallel parallel circuits. What you have in here is I'm just going to explain how a parallel circuit kind of set up. So this is an example of a series. Every time we add something onto it in parallel, meaning they're running side by side, we call that a branch. So here I have one where I've added 1 branch, now I've added 2. But what you'll notice is current in a parallel circuit will increase with every branch that I add. So if this is my series circuit with 1 amp, all the way around everywhere we go, it's going to be 1 amp. But if I add a branch onto it to make it a parallel circuit, I'm now going to add these amps together. So rather than just 1 amp for the entire circuit, I now have 2. And it was the same for this. If I have 1 amp here as a series, as I add branches to it, my amps are going to increase to 3. That's a little bit different though than voltage. In voltage in a parallel circuit, the voltage from the battery, let's say example 4 volts, is never going to change across the voltages of the loads. The voltage stays the same in a parallel circuit. So again, if I have 4 volts here, I'm going to have 4 volts going through that light bulb and 4 volts going through the second light bulb. All right, so it doesn't matter how many branches you add, the voltage will not change. So this is just a quick summary of the ideas that we've covered in both the videos. Current is the same and voltage splits in a series circuit. In a parallel circuit, the current splits up, but the voltage stays the same. So to kind of practice the world of parallel and series circuits, there's this game which I will link to you called Crack the Circuit. Now it's kind of fun. You get to build different stuff, and you get to start with level 1. I think I've played it a few times, so I think I'm on a different level. There's different switches here that you can use. You can find out if when you have one, if this affects the other. So you can see how I took this light bulb out, and this light bulb was still lit. That's an example of a parallel circuit because I know that they're not on the same circuitry, so that I know that I can take one out and it doesn't affect the other. If I leave that in, it should do the same here. I can also see if using one switch will keep one light bulb on or the other. And then what you do is you build it in the bottom. Okay. Now it's going to take me a while to go through and build it. I'm not going to build it. I'm just going to go back. But if I was to pick a level and just do something simple, let's see here. Let's go back to the very first level. Okay, here's my light bulb. It's showing how does this work. I'm going to put my battery, I'm going to put my light bulb, and then I'm just going to connect them to show that that is my circuit. Okay, it gets more complex as you go along, and it gets a little bit harder. It adds the switches in, and so you have to make sure that you add the proper switch in the proper place and that you can turn it on, right? And then it goes through, so these are example of series circuits. This one, again, they're going to ask you to test the light bulbs. If I take that one out, ooh, the circuit is broken. There's no light in this one. So this is an example of a series circuit when the lights don't stay on if I take one out. This is like a really old example of an old Christmas tree I had when I was younger. One light burnt out, they all burnt out. So there you go. So you can play this game. It's kind of fun. It gives you an idea between parallel and series. It doesn't talk about voltage and current, but it gives you a little bit of time to build. I hope you have a great day, and I'll talk to you later.